from the University of Palermo, and my colleagues are Stella Cernia and Tommaso Ingracia from the same university, same department. So we make research, we are making the research on the definition of 2D size and shape, definition of a defect inside a plate, which is our problem to solve. We have a plate with a thickness, and we have some defect inside or in a side of the plate. We can approach our plate just from one side of the plate. And we want to analyze this plate, we want to measure this defect and the position and the depth of the defect inside the plate to decide if the defect is a problem or not for the plate, for the application, which is the technology we use to analyze this plate. We use a laser ultrasound system. It's a method that uses two lasers, one for generate the wave, the ultrasound wave, is a infrared pulsar laser, and which generate a lot of wave starting from this point of the plate, in the surface of the plate. And after, the wave comes inside the plate and is reflected or refracted from the materials. And in another point, we use another laser, a continuum laser. It's a green laser, a visible laser. It's part of an interferometer that measures the displacement of the point of the surface perpendicular to the plate. The two lasers are placed in a distance, and we can fix this distance to read here with the interferometer something we want to know. For example, we use calling T, the thickness of the plate. We put the two lasers far 2 times T. In this way, we can measure, we can read in the point of reading the two waves. One is the subsurface wave, longitudinal waves, is the first to arrive here. You can see. Yeah. This is the, we can see, this is noise and this is a wave. This is very little, but it's clear to see this wave. And this is the first one wave that arrived in the green laser. The second wave is this one, that is a wave that comes inside the material, is reflected from the other side of the plate, and come back to the receiver point, and this wave is more clear than the first one, because this distance is optimized to amplify the displacement of the points here in the receiver point. If we make a scan moving the two lasers on the plate, we can obtain a map. This is a B-scale map. We can see here this red stripe is this part of the wave. The blue stripe, this one blue stripe, is this part of the wave, the first one wave. without defect, this is the map. We don't have anything to analyze because we see just the waves to here that arrives to the receiver point. If there is a defect, we have more effect because more than the two waves before, we have a third wave that is reflected by the defect. And for example, we have this perturbation of the map. And we can observe two things. We have this parabol. This is like a parabol. This is due to this reflected wave. And the second one effect is the interruption of the biggest one wave. We have two interruptions because when the system goes in this part, the defect comes inside, interrupt the wave because there is a hole and the wave cannot arrive to the receiver. After the defect comes inside, then the wave restarts, and again the defect comes here and stop again the wave. And then we have two effects of the defect to the map. We use the second one, the interruption of the wave, to measure the size, the position, and the depth of the side. How we make? Okay. The red stripe is the magnitude of the reflected wave, the biggest one. When the defect enters the root of the wave, the red stripe disappears, and the magnitude of the wave falls down. We can think to draw the root of the wave on an image of the section of our sample, of our plate, and we can color as a white line when there is the wave, and black line when the wave is disappeared. We can draw the section. This is a section of our plate, and every couple of stripes, you can see here the first one is white because we have a magnitude of the wave. When we found the defect, part of the wave, the two lines of the wave, are disappeared because there is no wave there. But if we assign a color to a pixel as the biggest one color, the biggest one level of gray to the pixel due to the superposition of more lines, we can see these three holes, these three zones black. This one is the defect. That one are shadows. For example, we can measure in this way the each position of the defect, find the center of this rectangular or round. We can find size of the defect, measuring with a threshold. We can measure the dimension of the defect of the round that contain the defect, and also we can measure also the depth of the defect, of the center of the defect, and we have also this shadow. We cannot exclude the presence of some defect inside, but this is a defect of this method, but we can fix with other approach, changing the layout of the laser. We can reduce or remove this shadow from the image. At this time, we found, I repeat, dimension, x position of the defect, and dip of the defect. This is a new approach because we generate a section, an image of the section of the plate. And from the original one maps, this is a very different image. We can use this image to find physically the defect. Now we want to find the shape of the defect. We have, in this application, we have a circular defect of 2 millimeter in a 5 millimeter plate. And we can find this shape. How we can? We can study the parabol. The parabol we found before. What is it? Is the time of flight of the reflected wave from the defect. When the defect arrives, the parabol, the wave make a distance, make a route like this one, and we cannot know which is the exact route the wave make inside the plate, but we can know the sum of this route come in that time. Then we can build an ellipse. This is an ellipse with that is the geometrical plate distance from these 2 points that are the generate and detect points. The envelope of this parabol, this ellipse, can help us to find this part of shape. We construct an ellipse to this part of the envelope. We can use other geometries, and we can study on the right geometries to fix here, and we are starting to look together this image with the first one of the section of the plate to generate the better flow, the better defect in the plate. Including, we study a new approach to size and shape definition of the defect, and the method uses a B-scan image built by a laser UT system. The method allows us to determine the position, the size, and part of the shape. We are studying on calibrate, refining this method. It's very new for us, and making more work on the layout of the lasers and the type of scanning. We want to analyze a 3D shape, 3D position of the defect or size of the defect. Thank you.